So as we start to try to represent power series, we're really moving in this direction where we have a some sort of a fraction, and we're trying to figure out what a is, and then we need it to be 1 minus r, which is really the sum of this power series. So we're not generally going to be starting with the power series. We're going to be starting with a fraction in this section and trying to either identify what it is or have it work. Now, when we have an actual geometric series, if r is greater than or equal to 1, it diverges. If r is less than 1, it converges. So if we can figure out what this term is, r value itself, if this is less than 1, it converges. We don't really even have to check the endpoints, because if it was 1, you'd be adding up a whole bunch of terms. They wouldn't drop out. R needs to be less than 1 for this to converge. So let's see how that works. So we want to find a power series centered at C, then find the interval of convergence. Okay, so for these, the interval of convergence is a little bit easier. Now, the first thing you want to have is, remember, we want this to be in the form of a over 1 minus r. So our r is going to have some sort of x in there, and we want it to be centered at negative 2. So the first thing I would do is I would write this as 5 minus, and then we want it to be x plus 2, because that would be centered at 2. Now, we can't just add in 2 into the bottom. We have to be balanced with this. Think about like completing the square. Whatever you do, you undo. Now here's the part that's the trickiest. I'm going to add 2 in here, but to balance that, I would subtract 2. Now, if I put a plus 2 and minus 2 inside the parentheses, it's kind of easy to see that that's the same. But when you distribute this negative into the both of them, this negative with this negative 2, really when it becomes on the outside, you get a plus 2 as well. So it looks like I'm adding 2 and adding 2, but I'm not really. This is a negative 2 and this is a positive 2. But now it's centered at negative 2. Alright? So we got it centered in the right spot. Let's clean it up a little bit. We get 4 over 5 plus 2, which is 7. So 4, doesn't look quite like 4, minus x plus 2. Alright, so we're centered in the right spot. Problem is we need this to be a 1 out here. So all we're going to do is divide both top and bottom by 7. Now I need to make sure I divide everything by 7. Now I'm good. So 4/7 is the a. I've got my 1 minus x plus 2 over 7. Now I'm in the right form. This is r. And I need my radius to be less than, well, it's really the absolute value of the radius, less than 1. Now the absolute value doesn't do much for us here, but we have x plus 2 over 7 is less than 1. If I multiply both sides by 7, just like what we did a couple seconds ago, we get x plus 2 to be less than 17, but 7. So if we think about the number line, we put negative 2 on the number line, and we go 7 to the right, we get 5. Go 7 to the left, we get negative 9. So our interval convergence, and we don't really even have to worry about the endpoints here, is going to be from negative 9 to 5. And that's really it. So we'll do a couple more here in a second. So for number 2, one of the things we have to make sure that we're able to do is talk about the center again. So this one's kind of out of order. So the first thing we're going to do is we're going to rearrange it, and we're going to switch everything around. So the easiest way of doing that, because we want it to be 1 minus r, is we're going to multiply top and bottom by the negative. So negative 3 over 1 minus 2x. Alright, that's a little bit better. Now, we want it to be centered at 2, so we're going to put a parenthesis here, and it needs to be minus 2, so now that's centered at 2. Now, the hard thing is figuring out how we're going to balance that. So if I was to distribute this negative 2 in here, I would get a positive 4. So the only way to combat a positive 4 is with a minus 4. Okay, so let's see what we got. Combine like terms again. Negative 3 over negative 3 minus 2. This is x minus 2. Okay. Now that I'm looking at it, dividing by that negative 1 or multiplying by that negative 1 in the first stage put us in the right form. However, here in a second, we're going to see that that's it was an extra step that we didn't really need to do. So we still need this first number to be a 1. So we're going to divide everything by negative 3. Now that might seem like it's a problem here, because these two negatives are going to cancel. Well, let's see what we get. We get a positive 1. We don't need our plus at all. 1 over, 1. Now we get a plus, but actually, I can leave this as minus and negative. Remember, it's in the right form, where this negative 2/3 x minus 2, the whole thing is the r. So if I do the two negatives together and cancel out and make a plus, then I don't really fit the form, but minus negative is no problem. So we want the absolute value. Remember, r could be negative. Oh, there we go. Negative 2/3 x minus 2, and I want this to be less than 1. Okay, well, the negative goes away because of the absolute value. And we multiply by the reciprocal, 3 over 2, to both sides, and we get the absolute value of x minus 2 being less than, well, 3/2, which means the radius is 3/2. And I always like to do these in the number line to figure out what the actual interval should be. So if I'm centered at 2, and I'm going 3/2 to the right, I don't care if we do this in decimals or fractions. Decimals might be easier, so it's 1.5, so we're going to 3.5, and then to 0.5. So, not negative 5.5, sorry. So our interval of convergence is 0.5 to 3.5. And remember, since we're not doing the ratio test, this fails if it equals 1. So the nice thing about these is we don't even have to check our endpoints. Alright, let's move this down a little bit, see what else we got. So what we're going to do here in number 4 is actually we're going to think back to the last chapter and say, if this is an integral, how will we do it? Well, it looks like partial fractions to me, so let's see what happens if you get partial fractions. So we got 2x and 2x, we get factor at the bottom, and then 2x and 1x, and then 2, you put the 2 with the 2, so 2 here and 1 here. Let's see what we got. We got 4, minus 1 would be 3, so looks like we can factor it just fine. And then we set our 4x minus 7 over the bottom, really right, a over 2x minus 1, it's an a, not a 9, plus b over x plus 2. Alright, multiply through by our LCD, we get 4x minus 7 equals a times x plus 2, plus b times 2x minus 1. And then we set x to be negative 2. Let's see here what we got on the left. We get negative 8 minus 7 is negative 15. Bigger numbers on this one. Equal to, well, the a drops out. And we get b to be, it's negative 4 minus 5, 5b. And then b equals 3. And then for a, we're going to set x equal to, well, in this case, 1/2. Because that would be what would make b drop off. Well, the good thing on the left side is 4 times 1/2 is 2, minus 7 is negative 5. Okay, equals a times 1/2 plus 2 would be 5/2. Multiply both sides by 2 over 5, and you get a to be negative 2. Oh, nice, neat, simple whole numbers. That's nice. So what we're going to do is we're really going to split this up into the two partial fractions. So a, which is negative 2, over 2x minus 1, plus b, which is, 3 over x plus 2. Now each of these separately is actually pretty easy to do and kind of already basically ready to go. So for the first one, you just got to swing it. We're going to multiply top and bottom by a negative, and we get 2 over 1 minus 2x, which is exactly in the right form, plus the 3. We're going to have to get rid of this 2 here, so we're going to divide both top and bottom by 2. 1, and that's a positive x, so we're going to do that whole minus and negative trick that we did before. Alright, so each of these has its own radius and convergence, but together they have to kind of go together. So when we do each of these, we're going to do them totally separate. Let's say our 2x, that has to be less than 1, so divide by 2, x has to be less than 1/2. So this one would go from negative half to positive half. And the other one is a little bit simpler, just the negative x, which goes away. And this one is a radius convergence from -1 to 1. 0 in the middle, of course. So which interval convergence do we use? Which radius do we use? Well, we can't use the bigger one, and because the reason is, if you pick something like 0.75, that would be outside of this interval convergence. So you would have one series that would converge and the other series that wouldn't converge, which really wouldn't make any sense. So we have to take the most restrictive values. So our radius is going to be the smaller of the two. So radius is 1/2, and our interval convergence would be from -1/2 to 1/2. So if you ever have competing radius of convergence or interval convergence, you always have to take the more restrictive of the two. Because if you try to take the least restrictive, you'll end up having it work sometimes and not work other times, which we don't really want that to happen. The idea behind the radius convergence is as long as we stay in this radius, any value that we find for x, the power series will work. If we stray from that value, if we get too large or too small, then we end up finding that our power series is not an actually good representation. So a couple main points here. The basic thing is you have to fit the form a over 1 minus r. Once you can get there, you need the absolute value of r to be less than 1. Not less than or equal to 1. It needs to be less than 1. That tells you what the radius is. It also, once you know what it's centered at, gives you the interval convergence very quickly. This number out here has to be a 1. A can be anything it wants to, but it can't really have an x involved. So up here in number 4, it looked like it was going to be a problem until we did the partial fractions. So if it looks like you would do the partial fractions for the integral, that's what you're going to do for the power series.